బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్ నిజమైన విద్యకు నిలువెత్తు సాక్ష్యం. 20 ఎకరాల సువిశాల ప్రాంగణంలో కళాత్మక నిర్మాణాలతో స్వచ్ఛమైన ప్రకృతి ఒడిలో ఆత్మీయతను ఆస్వాదిస్తూ విద్యా సౌరభాలు వెదజల్లుతోన్న చదువుల నిలయం బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్. క్రమశిక్షణకు మారుపేరుగా సంస్కారం, నిబద్ధత కలిగిన బోధనతో పాటు మానసిక, భౌతిక వికాసం కోసం సువిశాల ఆట స్థలంలో వ్యాయామం, యోగా, వాలీబాల్, త్రోబాల్, క్రికెట్ మరియు ఖోఖో లాంటి ఆటలు రోజువారీ టైం టేబుల్లో భాగం చేయడం బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజీకి మాత్రమే సాధ్యం. బాలబాలికలకు ప్రత్యేక హాస్టల్ వసతితో రుచికరమైన పౌష్టికాహారం, 24 గంటలు అందుబాటులో ఉండే సీనియర్ లెక్చరర్స్, విద్యార్థుల మెదడుకు పదును పెట్టే ఫిజిక్స్ ల్యాబ్, కెమిస్ట్రీ ల్యాబ్, బొటనీ ల్యాబ్ మరియు జువాలజీ ల్యాబులు, నీట్, జేఈఈ మెయిన్స్ మరియు జేఈఈ అడ్వాన్స్డ్ పోటీ పరీక్షలకు సన్నద్ధపరిచే విద్యా ప్రణాళికలతో బీరం సుబ్బారెడ్డి గారి ఆధ్వర్యంలో, బీరం శ్రీకాంత్ రెడ్డి పర్యవేక్షణలో అమ్మ లాలన, నాన్న పాలన, గురువుల బోధన కలిగిన త్రివేణి సంగమ సమాహారమే బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్. అడ్మిషన్లు ప్రారంభమైనవి. సంప్రదించండి. బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్, బీరం శ్రీధర్ రెడ్డి నగర్, NH40 రోడ్, ఖాజీపేట్, కడప. సెల్ నంబర్ 7036666777. బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్ నిజమైన విద్యకు నిలువెత్తు సాక్ష్యం. 20 ఎకరాల సువిశాల ప్రాంగణంలో కళాత్మక నిర్మాణాలతో స్వచ్ఛమైన ప్రకృతి ఒడిలో ఆత్మీయతను ఆస్వాదిస్తూ విద్యా సౌరభాలు వెదజల్లుతోన్న చదువుల నిలయం బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్. క్రమశిక్షణకు మారుపేరుగా సంస్కారం, నిబద్ధత కలిగిన బోధనతో పాటు మానసిక, భౌతిక వికాసం కోసం సువిశాల ఆట స్థలంలో వ్యాయామం, యోగా, వాలీబాల్, త్రోబాల్, క్రికెట్ మరియు ఖోఖో లాంటి ఆటలు రోజువారీ టైం టేబుల్లో భాగం చేయడం బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజీకి మాత్రమే సాధ్యం. బాలబాలికలకు ప్రత్యేక హాస్టల్ వసతితో రుచికరమైన పౌష్టికాహారం, 24 గంటలు అందుబాటులో ఉండే సీనియర్ లెక్చరర్స్, విద్యార్థుల మెదడుకు పదును పెట్టే ఫిజిక్స్ ల్యాబ్, కెమిస్ట్రీ ల్యాబ్, బొటనీ ల్యాబ్ మరియు జువాలజీ ల్యాబులు, నీట్, జేఈఈ మెయిన్స్ మరియు జేఈఈ అడ్వాన్స్డ్ పోటీ పరీక్షలకు సన్నద్ధపరిచే విద్యా ప్రణాళికలతో బీరం సుబ్బారెడ్డి గారి ఆధ్వర్యంలో, బీరం శ్రీకాంత్ రెడ్డి పర్యవేక్షణలో అమ్మ లాలన, నాన్న పాలన, గురువుల బోధన కలిగిన త్రివేణి సంగమ సమాహారమే బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్. అడ్మిషన్లు ప్రారంభమైనవి. సంప్రదించండి. బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్, బీరం శ్రీధర్ రెడ్డి నగర్, NH40 రోడ్, ఖాజీపేట్, కడప. సెల్ నంబర్ 7036666777.
Grade 2 much Hello everyone, good evening. Yeah, tomorrow class timings won't be same. Tomorrow is holiday. You can enjoy it. All of you able to hear my voice? Audio clear? Good evening, Akhil. Jigneshwar, good evening. Jigneshwar, okay. Geetika, good evening. Good evening, everyone. Akhil, happy Science Day. Kavya, good evening. Charan, good evening. Yeah, Navesri, Sai, Charan. Good evening, everyone. Tomorrow is holiday. You can enjoy. Again, we'll meet on day after tomorrow with a different class. Happy Science Day to all. I think all of you enjoyed in your school. Okay, Science Day. Let us learn little science also. So, who is the best? I mean, which is the best in science? Science is comprised of so many things, no? Like mathematics is there, physics is there, chemistry is there, biology, zoology. No? Okay, what do biology have? Okay, very good. Ammo, you rename it. It's not. Don't keep your nicknames. Keep your full name. That will be good to call you. Okay. Yeah, Vijay, all subjects are. Okay, but with the time you will change it. Yeah. So most of the people are saying biology, or only Ammu is saying physics. Realme 3 Pro, very good. Professionally, you are doing all the things, so it's very good, but change your name. Okay. So I think all of you remember what we have done in the last class. Okay. Please rename with your proper name. Okay. Yeah, Karani, correct. Refraction we were doing. Okay, na? So I think some people need to join. Usually the number is less, it seems. Yes. So we were doing the refraction. Suppose a ray goes from rarer medium to denser medium. Okay, na? Then the ray of light passing from rarer medium to denser medium. So we discussed this is the normal. We discussed this is normal. Okay, na? This is the incident ray. Angle of incidence we discussed. Angle of refraction we discussed, right? And we discussed even when ray travels from rarer medium to denser medium, then it will bend towards the normal also. Some people answered towards the normal. And if it goes from denser medium to rarer medium, it will go away from the normal. Let us see little discussion about these things. Okay. And some people were asking me about, sir, explain current electricity also. But what I'm saying is, as I started this topic, I'll continue a little bit. And then after that, we'll shift to the current electricity. But stick to the class, you will learn something definitely new. No doubt. Okay. Whatever you learned in the schools, you will learn more than that. You will learn more, what they say, that logical, and at the same time more explanatory also. Vijayeshwar, chemical bonding, huh? Okay, that is related to chemistry. Your chemistry teacher will take care of it. Okay, Vijayeshwar? Actually, in 10th standard, you will study physics and chemistry as together in one book, right? Then that will become 2 books when you come to the 11th and 12th standard. Okay, you will have separate book for physics, separate book for chemistry. Okay, yeah. Very good, Amma. It will bent towards the normal as it is moving from rarer medium to denser medium. This is a normal incident ray. Then this is called as angle of incidence, and this is called as angle of refraction. R is called as angle of refraction, right? Refractive index of rarer medium, I'm taking as mu r. Refractive index of denser medium, I'm taking as mu d. So already we discussed last class that denser medium will have the more refractive index. We will call in that way all. If refractive index is more, we call it as denser medium. If refractive index is less, we call it as rarer medium. Okay? So that means here, what is the inequality? Mu d is greater than mu r. Refractive index of denser medium is greater than refractive index of rarer medium. That already we know, right? Okay, we have seen all these things last class. Now we are going to learn a different phenomena or very important phenomena regarding the refraction, which is called as Snell's law. Okay, which is called as what? Snell's law. How many of you know Snell's law? How many of you know Snell's law? Pardo, Sandhya, raise your hand. Let me see. Aishwata, Teja Reddy, Sharan Teja Reddy, Akhil, Vishnu, Jigneshwar. Akhil, sign up by signer. That's it. Okay. Okay, I can see some around 10 members raise their hand. Geetika, raise your hand. Sandhya, do you know Snell's law or not? Ashwita. Okay, Naveshri, very good. Jigneshwar, Sainai by Sainar is constant, very good. Sanjay, Sainai by Sainar, then what after that? Sharan, Teja, Reddy, very good. Nice. Yeah, very good. Good response. Geetika, correct? So some of people are saying, but in your textbook, state board textbook, it is something like this. Sin I by sin r is equal to constant. Simply take state board textbook, they have given sin I by sin r is equal to constant. They left it here in your textbook. So maybe in CBSE they have given n1 sin I is equal to n2 sin r. Right? Am I right? Rishta, very good. Tarani also know it. So in different books, different way as given. But I'll tell you one way so that you don't get mistake. Okay, now you can apply anywhere. Anywhere when it comes to more number of mediums. We are talking about only two mediums here. Here, how many mediums I have taken? I have taken one medium, rarer medium, other medium is denser. I have taken only two mediums, right? If I take more number of mediums, so suppose if I take 4 different mediums, a ray is going from first medium to second medium, again second medium to third medium to fourth medium. Understood? When ray is going across 4 different mediums, then this, if you are applying the same formula format, then it will be difficult. Okay, so let us go with an easy one so that you will understand. At the same time, you will feel easy in applying this Snell's law. Okay, then what is the easiest form is, yes, of course, sin I by sin r is equal to constant, but what is the constant value? That is not given. Okay, you can keep your hand lower. Okay, hand sign you remove it. Okay, thank you. Yeah. So sin I by sin r is equal to constant, but what is the constant value is not given, right? Now we are going to learn what is the constant value. How to decide this constant value? That is the thing what we are learning today. Okay. Now further, Snell's law I'm writing as refractive index of medium. Follow this carefully. Okay. Stick to me. Refractive index of medium multiplied with sine of angle in that medium. Sine of angle in that medium is constant. Understood? Refractive index of medium multiplied with sine of angle in that medium is constant. If you follow this, then you can solve so many questions very easily. Okay, so I'll stand here so that you can see everything. Okay, so concentrate on this phenomena what I wrote. you will get this exactly same. But the format is in such a way that if you follow this principle, you don't get any mistakes. You will get a simple way of solving the questions. Okay, na? So I am not following the textbook again. This is the principle to solve the questions of physics. Okay, na? Not following the textbook. So don't write down this one in your board examination. You don't get marks. Okay, don't follow this in board examination. In board examination, if anybody asks you, board exam is in your 10th class exam. In your 10th class, if any question comes, 10th class exam, you write down sin A by sin R is constant or sin A by sin R is n to by n. If you know n to by n1 logic. Whatever is given in the textbook, you write down that one. But remember this to solve the questions. To approach the questions easy. Understood? So this is the one problem in physics. In physics, writing board exam, writing the question and answer is different. Solving the problems is different. Okay? Visual with experiment. Experiment means I can show you some video if you want. So I'll ask you to play some video if you want. In the next class, I'll make a submit. I'll find you some video so that you can see the video. But experiment means it is tough for us right now, according to the situation what we are having. Okay, Vijayeshwar? My N1 sin A is equal to N2 sin R. Okay. What is N1? What is N2? That we need to understand. Then only that formula will work. Otherwise, that formula won't work. Okay. So remaining you can understand that refractive index into sin of angle in that medium is constant. Means this product does not change. So let us apply the same product to here. So first you take the rarer medium. What is the refractive index of the rarer medium is mu r. What is the angle in this medium? Means I. I is the angle in this medium. Mu r is the refractive index of the medium. Then I write down mu r into sin of I. Getting the point? Mu r into sin of I is equal to, why it is equal? Because it's constant. What is the meaning of constant? Constant means same. The product is always same. Okay. Now I take the second medium. Second medium refractive index I am writing as mu d. Mu d is the refractive index multiplied with what is the angle? Sin of angle in this medium. In this medium, what is the angle is there? R is the angle is there. So I write down sin R. Okay, na? Mu R is the, I am repeating again. Please concentrate so that you will learn a good thing. Okay. Refractive index of the medium is the mu R. What is the angle in that medium? I. So refractive index mu R sin of angle in that medium is I is equal to, because constant. Constant is same. The product has to be same. Then what is the refractive index of the denser medium? Mu D. Sin of what is the angle in this second medium is R. So sin R. Okay, na? So mu R sin A is equal to mu D sin. So hope all of you understood. Any doubt, let me know. I'll repeat. I'll explain in another way also if you want. Okay, tell me. Okay, by the solving the questions also you will be connecting to this formula in very well manner. Okay, na? This formula koncham baga connect avalante mana okati rendu questions solve cheyali. We will do that. First write it down. So I hope you kept a separate note for this. Okay, koncham notebook pettukondi, you write down everything. Definitely these are useful in your future. No doubt in that. Okay. So wrote down. So from this you can understand why ray will bend towards the normal, why ray will go away from the normal. That also you can find out from this. That logic I'll explain. Okay. So I wrote this. I wrote this part. Okay, now let us go for the other thing. So I draw the two diagrams. Both the diagrams are very much familiar to you. Okay, you know already those diagrams. So let me draw first, then I'll explain. So suppose this is the medium boundary, medium separating line. This is the rarer medium, mu r. This is rarer medium. And mu d is the refractive index, which is denser medium. So everybody knows that as the ray travels from rarer to denser, it will bend towards the normal. This is I and this is R. Now my question is, which one is greater? Angle of incidence is greater or angle of refraction is greater? Answer me first. Which angle is greater? Angle of incidence or angle of refraction? Sharon, check it again. Very good. So I cannot see some names. Amu correct. Tarni correct. Very good. Very good. Vidika correct. Navishri correct. Navishri, yes. Navishri correct. Joshi Prakash correct. Very good. Charan Sai correct. Perfect. Gautam correct. Nice. Nice response. I is greater than R. Fauzia. Fauzia, you want me to unmute? Fauzia, do you have any doubt? Fauzia, unable to hear you, Amma. Come again. Tell me again. Okay, Fauzia, you use the chat box. I think audio is not proper. Okay. So I is greater than R. It's a clear thing. Okay, I is greater than R. Perfect. Okay, most of the people also answered. Very good. Vijay already correct. The angle of incidence is greater than angle of refraction. Now let us see why it is. Okay. Now I'll take the second scenario. Second scenario I'm taking. Now I'm taking this is the denser medium, which is having the refractive index mu d, and this is the rarer medium, which is having the refractive index mu r. Then if a ray goes from denser medium to rarer, there is a difference. I think you identified. That's why wanted I drawn the two diagrams. Okay, side by side. Very good, okay. Nice, nice response before a question. I didn't ask actually. Very good. Moves away from the normal. Perfect. So then this is the angle of incidence I. Then this would be the angle of refraction or refracted light, and this is the angle of refraction. Okay, now ray bent away from the normal. This is the actual path of the ray, right? This is the actual path of the ray. The ray has to go in this way if medium is not there. This is called as actual path of the ray. Now ray will bend away from the normal. Here, this is the actual path of ray. Okay, ray will bend towards the normal. I think all of you know these phenomena. This is not a new thing. This is what you learned in your classroom, right? But the question is, why ray will bend away from the normal when it is moving from denser to rarer? Why bend will move towards the normal when it is moved from rarer to denser? Anyone want to answer? Vivekananda correct. Here R is greater than I. Okay, Sanjay correct. Due to its velocity change, perfect. Ammo, tell me what is the answer? Akhil, due to refractive index of medium is okay. That is already we know, because of refractive index only this is happening, but exact reason we require. Due to velocity change, that is also okay, but that's not complete reason. Velocity changes, if you want to identify, then you need to know the wavefront logic. Okay, waves, light travels as a waveform, wavefronts. As wavefront is moving from one medium to other medium, how that wavefront is changed, how that wavefront changes, changes. A lot of things you need to know. That is a big discussion. We don't want to go into that phenomenon because in your 10th standard that's not there. When you come to 11th and 12th standard, we will discuss that part. Due to refractive index of a medium, due to velocity of light, or due to change in speed of light, these are all reasons, no issue. These are all reasons, but those are the partial reasons. So let us see the complete reason according to our knowledge or according to the knowledge of 10th standard. Okay. So already we know the sense, right? What I wrote mu into sine of angle theta is constant. Am I right? This is just nice we know, na? Already I told. Already I told that refractive index of medium into sine of angle in that medium. I wrote theta. Theta is nothing but either I or R. Either angle of incidence or angle of refraction. Okay, na? Mu into sine theta is constant. This is the phenomena what we know already. Clear? So now let us see. Suppose if refractive index increases, refractive index is increasing, then what about the sine value? See, product of two values constant. To understand better, I will go another way. X into y is equal to, let us say that x into y is equal to 24. X into y is 24. 24 is a constant. But x value we can change, y value we can change. Right? Suppose if I keep x value 1, what is the y value? 24. If I keep x value 2, y value will become 12. If I keep x value 3, y value will become 8. Am I right? If I keep x value 4, y value will become 6. What do you observe in this pattern? In this pattern, something is there. Have you observed anything? Have you observed anything in that pattern? Numbers. You see the numbers? Have you observed anything? In this, see, x value 1, 2, 3, 4. That means x value is increasing. Then y value 24, 12, 8, 6. That means y value decreases. Okay? Are you understanding? X into y is equal to 24. If x value increases, I write down in this way. Upward arrow is increasing. Then y value decreases. Similarly, you think in reverse way. If y value increases, then x value decreases. If one value increases, other value has to decrease. Get it? So same idea you can apply here. If mu value increases, sine theta value has to decrease. If one value is more, other value should be less. If sine value is decreasing, that implies theta value also decreases. Okay, if sine value is decreasing, theta value also decreases. For that, I will write down one more table. So I think you understood this logic. This is you need to understand. So how many of you know sine value? Sine 0 degree. Now you answer the values of sine 0, sine 30, sine 45, sine 60, sine 90. How many of you know these values? Sine 0, sine 30, sine 45, sine 60 and sine 90. Okay, Rishta, you know, Tadmi also know, very good. Lakshmi Bhavana, very good, you also know it. Pardho, Ignesh, Akhil, Vishwardhan, Vigneshwar, Harita, I think so, right? Yes, Harita. Chart में स्कोर चाहिए चार्ट स्कोर चाहिए हाँ well charge just very good. So I am unable to see the chat box, that's why I couldn't respond properly. Okay, good, nice, very good. So many people are answering. Jigneshwar, very good, nice. Sandhya also answered. Fauzi also answered. Amma also answered, very good, nice. Naveshri also answered, very good. Rajeshri also answered, very good. Okay, see, I don't want correct answers, I want your response. Okay, so I never want your correct answer. I want involvement in the class. You should respond whatever you know, whether it is correct or wrong, let it be. If it is wrong, we will learn it. If it is correct, we will keep it. Okay, that is the phenomenon I follow. No, I am not talking about refractive index 0. Refractive index 0 means what? What is the meaning of refractive index 0? That means speed of light is infinite in that medium. Okay, somebody, I can see in the chat, somebody wrote refractive index 0. That never happens. Don't think that. Okay. Very good. Who is asking for cos function? Vishnu. Vishnu, why they have not taken the cos function? Because there is some mathematics behind the Snell's law. Snell's law has to be derived by using the wavefront logic. So there will get 90 minus I, 90 minus R of something. Then it will become cos. Okay, the cos of angle, okay, cos of angle 90, then it will become sine. Sine of, if I am getting 90 minus something, then it will become cos. Sine or cos we have not taken. It is derived in the equation. Vishnu, okay? Vishnu, that's why we are using the sine. Otherwise, we will use the cos only. We don't have any particular love towards the sine. Okay? And we don't have any hate towards cos. Anything is okay, but that has to be derived. Direct formula. Okay, Vishnu? Vishnu, we discuss whenever we get time now, we discuss here. Okay, if possible, we discuss the wavefront, change of wavefront also. But I think that is too much for your understanding. Okay, so sine 0 is 0. Very good. So many people given the answer. Sine 30 is 1 by 2. 1 by 2 I'm writing as 0.5. Sine 45 degrees 1 by root 2. 1 by root 2. Root 2 you know 1 by 1.414, which will be nearly 0.707. Sine 60 is root 3 by 2. Root 3 is 1.732 by 2, nearly 0.8 something 6. Okay, and sine 90 is 1. These are the numbers. I think you learned till here, right? 1 by 2, 1 by root 2, 1 by root 3 by 2, right? Now you have to learn, or you need to know the values in terms of fractions or decimals. You see that also. Lakshmana, we will discuss that part later. Okay, don't worry. Lakshmana, you follow it. You will understand all these things. Don't worry. Exactly. Yashashri, na? Sai Yashwant. Sai Yashwant, perfect reason. Nice, very good. Nice thinking. Sai Yashwant, that all I am going to explain. Okay, you told it before. Very good. Okay. Yeah. So if you see all these numbers, what you identify? You identify the angles first: 0, 30, 45, 60, 90. That means what happens to angles? Angles are increasing. Angles are increasing, right? Then you see the values. Values also increasing. 0, next 0.5. Next would be what? 0.7. Next would be what? 0.8. Something. Leave it. Because we know that 0.8 is more than 0.7. And next one would be 1. So angles are increasing 0, 30, 60, 45, 60, 90. The values are increasing 0, 0.5, 0.7, 0.8 and 1. That means angle is increasing, value also increases, sine value. This only happens with the sine. The reverse will happen with the cos. For your better understanding knowledge of mathematics, okay? You see the cos. Now you try to make the cos. You see, if theta is increasing, what happens to values? For cos function, as values are increasing, angles are increasing, then values will decrease. Very good. Yes, Namesh, correct. Yes, I correct. Okay. For cos, it is a different story. That maintains a different story. For sine, if angle increases, value also increases. So that's why I wrote here. See, as the sine value decreases, theta value also decreases. Downward arrow means decreasing. And we are going with a shortcut. Okay, decreases. It takes a lot of time. No? That's why we are simply drawing an arrow down. Okay, if mu increases, sine theta has to decrease, theta value has to decrease. Same thing happened here. See, as ray is coming from rarer to denser, then what happens to refractive index? Ray is moving from rarer to denser. The refractive index of the medium is increasing. Then angle has to decrease. That's why R value is less than N. Simple. Got it? Now, whereas other case, now ray is moving from denser to rarer. As the ray is moving from denser to rarer, okay, then refractive index is decreasing, then angle has to increase. Reverse phenomenon. If refractive index is increasing, angle decreases. If refractive index decreases, angle increases. Same logic you can apply. H1 correct, Navesri correct, perfect. All of you understood this logic? Okay. Rarer to denser, refractive index is increasing. Then angle decreases. Then R value is less than it. Okay, if you want that, write down. I got this. So in this class you learned one important thing. What is that? As the angle increases, Sharon says, yeah, I'll explain it. Rajesh, I'll explain again. I'm explaining on. I'm continuing on. I'm not going to the other part. Sharon and Rajesh, I'll explain. Don't worry. Okay. So what I'm writing is here. See once. If refractive index is increasing, refractive index increases. Meaning, what is the meaning of increasing refractive index? Ray is going from rarer to denser. Denser will have the more refractive index, rarer will have the less refractive index. As the ray is going from rarer to denser, refractive index will increase. Right? If refractive index is increasing, what happens to angle? Angle has to decrease, already we discussed. As mu value increases, sin value has to decrease so that product will be constant. Okay? As the mu value increases, sin theta value decreases, then theta value also decreases. That also we learned in this class. You write down in your notebook a special case, or what do you say that? A special note, that is, as theta value increases, sin value increases. I am talking about only 0 to 90 angles, not other angle. As the theta increases, sin value increases. As theta decreases, sin value decreases. Reverse is the case with the cos. If theta increases, cos value decreases. If theta decreases, cos value increases. Okay? As the refractive index is increasing, then what happens to angle? Angle has to decrease. Angle has to decrease. Okay? That means R value should be less than I when ray goes from rarer to denser. Exactly, Vivekananda. Very good. Nice thing you understood. That is the phenomenon you can follow. Refractive index is inversely proportional to angle. Simple. You can go with it. No problem. Perfectly works. Okay. Next case you see. If ray is moving from denser to rarer, if it is going from denser to rarer, then what happens to the refractive index? Denser to rarer, refractive index. It is more refractive index, this is less refractive index. That means refractive index is decreasing. If refractive index decreases, okay? If refractive index decreases, then what happens to angle? Angle has to reverse, no? It has to increase. Then angle increases. Okay, angle increases. That means R value is greater than I. Initial angle is like final angle is R value is more than I. It moves away from the norm. Perfect. Who is this A? A Abhishek Bachana, Amitabh Bachchan. Clear? Okay, Sharon, very good. Rajeshri, you understood? Rajeshri, you told me to explain again. You understood or not? Sharon understood. Very good. Clear. Okay, very good. Nice. Rajeshri understood. Very good. Okay. So write down quick. What it down. I think you got some reason, logical reason why it is bending towards, why it is bending away from the norm, right? Okay, I will give you a small question. You try it, you will get it also. Okay. I love this part. Please don't take the screenshots. Okay. If you take the screenshot, it will be there in your mobile only. That won't be in your brain. Okay. To keep it in your brain, you have to write down. Write a notes. Okay. Write down a small notes. You don't need to copy everything, but write down whatever you like. But write it down. Don't follow the shortcuts. If you follow the shortcuts, you'll get the short marks. Okay. And more big rank also. For shortcuts, we'll give you big rank. Okay. So the question is very simple. Then there are two mediums. One medium refractive index is, let us say 1. Second medium refractive index is √2. Okay. One medium refractive index is 1. 1 means you can take air. Usually air refractive index is 1. Air is considered as an almost vacuum. The light speed is 3 into 10 power 8. Nearly in air also. So that's why we take air as a vacuum medium, equivalent vacuum. So one medium refractive index is 1. Other medium refractive index is √2. Then suppose there is a ray incidented at an angle. Let us say that 30 degree. Okay, ray is incidented at an angle of 30 degree. Okay. So if ray is incidented at an angle 30 degree, then what is the angle of refraction? Find R value. Let us see how many of you do it. Find angle of refraction. Find angle of refraction. Okay. Lakshmana, yes, correct. It is case of rarity tensor, right? √2 is 1.414.
Hello.
Yes, correct. A. So that's what, it's very tough to call you as A. Change your name, no? That's better. I think you might have a beautiful name. You keep the same name so that I can call you with your name. Huh? Okay, na? So please change it. Akhil, correct. Akhil, perfect. Sharon, how did you calculate 0.35? So wonder. I don't know. So it's very tough. Very tough for me to decide whether it is 0.35 or not. You tell me only what is say that fractions. Jigneshwar, you don't get 45. Jigneshwar, verify your answer, it won't be 45. Mahi 0.45. Do you have calculated to calculate? Mahi, you tell me in terms of fractions. Don't go for decimals. For the 15, you don't get 15. Mahi 15 now. 1/2 √2. Ramesh is correct. 1/2 √2. Mahi got it, very good. See, already I have given refractive indices. I have given one angle. We need one more angle. Right? So we have two refractive indices values. One angle is given. I want to know that one more angle. Then what to do? We'll go with a Snell's law. Already we know that. What is Snell's law? Will tell you that mu into sine of angle. Random number theta is the angle. Sine of angle is constant. Understood? Refractive index into, yes, Ignish, correct. Sine correct, but you forget to write down sine inverse. Two people. Mu into sine theta is constant. That is the phenomenon we know already. Okay, so we want to apply the same phenomenon to here also. What is the refractive index of the first medium? 1. Multiply with what is the angle in that medium? 30 degree. Then sine of 30 degree is equal to constantly same. Should be same, right? What is the refractive index of the second medium? Refractive index of the second medium is √2. Then what is the angle in the second medium? R. Then sine R. Got it? Understood? Then 1 into sine 30 is equal to √2 into sine. How many of you understood this one? This is physics. From here, completely mathematics. I told you no. To get an answer in physics question, you require physics as well as mathematics. From here, you will get entirely mathematics. But writing this equation is a physics. Mahi, very good. Again, I'm explaining. Listen to me carefully. Okay. Already we know that Snell's law will tell you refractive index. That is okay, Rajesh. No problem. If you have any trouble, let me know. I'll explain it again. Okay. Sometimes there will be issue with the network. Might past, video past. Okay. Maybe sometimes you are unable to hear my audio also. Let me know that we will discuss again. No problem at all. Okay. So we know that according to Snell's law, refractive index of the medium into sine of angle in that medium is constant. This we know already. Okay, we were doing the same thing today in this class. Now I'm applying the same phenomena to the given question. What is the given question is? Here refractive index are given 1. And what is the angle I have given? 30 degree. Here refractive index are given √2. What is the angle I am asking? So same thing we will apply. What is the refractive index of the first medium? 1. What is the angle in that medium? 30. So sine 30. Understood? Refractive index into sine of angle. Again, what is the refractive index is √2. √2. Second medium √2. And what is the angle in that medium is r. So sine r. So 1 into sine 30 is equal to √2 into sine r. Clear? Then sine 30 1 by 2 is equal to √2 into sine r. Then what is sine r value is equal to 1 by 2 √2. √2 you take it to other side. Then it will be in division 1 by 2 √2. Okay, then r value is equal to inverse functions. I think some of you people don't know inverse functions. Okay, so what is the inverse means? If you take the sine on this side, it's called as sine inverse. We have to write down something like this: sine power -1. Jigneshwar, you can go with sine A is equal to sine R is equal to mu2 by mu1. But if you interchange the mu2 and mu1, then you will get a wrong answer. That's why you got 45 degree. Am I right? Jigneshwar, I think you told the answer 45. I remember like that. Correct? Because mu2, mu1, no, if you reverse it, then your answer will be gone. That's why I didn't tell that formula. Okay? In all books, you will find one formula that is called the sine A by sine R is equal to mu2 by mu1. But there are so many chances to get mistakes in that formula. That's why I don't prefer that formula. I prefer this formula so that you don't get mistakes. Jigneshwar clear? Mahi clear? Very good. Nice. Jigneshwar, okay? Huh? So, if you take the sine on this side, it will become sine inverse. All of you understood this logic? These are called as inverse functions in mathematics. In mathematics, we get inverse functions under. So, sine inverse, what is the value left? 1 by 2 √2. So, this is the way to write down the answer. No need to identify what is the angle. To find out the angle, we require obviously calculator or logarithmic book. There is logarithm book where we can find out the angles also. Mahi is okay, no problem. You understood now? That's the important thing. Mahi, you understood, right? Rajeshri, do you have any problem?
Sir?
Yes, ma'am. Rajeshri, take ma'am.
Sir, once again explain, sir.
Which one you require?
Sine 30 is equal to √2 sine r, sir.
Sine 30 is equal to √2 sine r. See, same thing. Mu into sine theta is constant. That is the phenomena we are applying. Refractive index of the medium is 1. Angle is 30. That's why 1 into refractive index 1, angle is 30. So sine 30. Okay? Is constant means same. So same thing to be applied for the next medium also. Now you take the second medium, which is having the √2. Angle is r. So √2 into sine r. Refractive index into sine of angle in that medium is same. Okay? In every medium you can do the same thing. You can apply to all mediums. Getting my point? Then 1 into sine 30 is equal to √2 into sine r. In the place of sine 30, I wrote 1 by 2 is equal to √2 into sine r. Then I got r is equal to sine inverse 1 by 2. That's it. You can leave there. No problem. Rajeshri, you understood? Rajeshri, you understood? Huh? Let me know in the chat box. Understand? Very good. Okay, clear? Done? So now you see the different thing. Okay. So same thing we will extend little part. We will go little beyond so that how to apply this Snell's law, you will understand. You will understand the beauty of this formula. Whatever I told, no, be clear. Whatever I told, no, that formula has little what is it? Beauty in it. You will understand now. Add up this part. Okay. So now I am taking the multiple mediums. I am taking multiple mediums. That means what? Multiple mediums means so many mediums, not one and two. Okay. So something like this. This is the one medium, second medium, third medium. That is the fourth medium. I think you can see the four mediums. Yes. Got it? Yeah, many mediums. This is the one medium. This is the other medium. Third medium. Okay. And this is the fourth medium. There are four mediums. Then this is the mu1. This is mu2. Let us say mu3. This is mu4. Okay. Four mediums are there. Now you can write down the equation. Let us say that. Okay. This is air. Air means what is refractive index? 1. Then it will be 5 mediums. Air, mu1 medium, mu2 medium, mu3 medium, mu4 medium. Let us say that again air. At the end, air is there. Okay. Now, suppose that ray is incidented here. If ray is incidented, and this is the normal. Okay. At what angle? Let us say that angle is theta. At theta angle, it is incidented. Then it will go in this way. Let us say bend towards the normal. Next, bend away from the normal. Bend towards the normal. Bend away from the normal. Again, bend away from the normal. Understood? This is the way ray goes. Ray is moving in this way. All of you understanding? Joshi Prakash, not clear? No. Palak, it's not about TI. Total internal reflection I am talking about later. So this is the case where no total internal reflection is happening. Any other comments about this diagram? Let me see. Joshi Prakash, it is something like a different mediums I am taking. Something like, suppose one glass plate is there. Glass plate, on top of that water is kept. Okay, on below it, let us say oil is there. Getting my point? Then water is one medium, glass is other medium, oil is another medium. Like that, we are keeping different mediums. Okay, air is the first medium. Next, mu1 is the medium. I'm not specifying what is the medium, but you take it as a mu1 is the refractive index of the medium. Next medium refractive index is mu2. Third medium refractive index is mu3. Fourth medium refractive index is mu4. Again, air. It's something like a, what do you say that? Medium combination. 4 different medium combination. Above air is there. Below also air is there. Joshi Prakash, is it okay? Understood? You got any imagination or not? Geetika, okay, good, clear. Any other thing? Now tell me if you don't understand anything about the diagram, I'll explain again. Don't worry. Because if you don't understand the diagram now, you cannot understand this logic. That would be correlated. That is the only problem with the Joshi Prakash understood. Very good. Yes. That is the only problem with the physics. Okay. Yeah. Now let us say, suppose this is the normal. Okay. In third medium, the angle is, I am taking the angle in third medium. Third medium angle is theta 3. Third medium angle is theta 3. Are you able to see, Vishnu? Vishnu, perfect. That is the idea. Incident and emergent ray will be parallel teacher. Should be parallel teacher. I'll discuss it. Wait. I'll discuss it. First of all, I want to know that what is the relation between the theta and theta 3? Can we find out relation between theta and theta 3? See, theta is the angle in, very good, Lakshmana, perfect, lateral shift. Theta is the angle in first medium. Okay, no, they are not equal. Theta is the angle in first medium. Theta 3 is the angle in mu 3 medium. Okay? Theta 1 is greater than theta 3, Vishnu, okay? Lakshmana, yes, correct. Lakshmana, perfect. So you differently typed it, but I understood. That's the correct answer. No problem. Okay, all of you listen. See, this is angle in one medium. Refractive index is 1. A refractive index is 1. What is the angle in third medium is theta 3. What is the refractive index is mu 3. Now you can apply this Snell's law directly. What is the Snell's law? It's saying that mu into sine of angle in that medium is constant. Right? So this is the beauty of this particular formula. What is the beauty? Not only for two mediums, you can apply for any two different mediums. Any two different mediums also you can apply. You can apply directly from the first medium. What is the first medium refractive index? 1. 1 into sine theta is equal to 1 into angle in that medium is theta. 1 is the refractive index, theta is the angle in that medium. So 1 into sine of angle in that medium is equal to constantly same. What is the refractive index in this medium? Mu 3. What is the angle in this medium? Theta 3. Then I can write down mu 3 into sine theta 3. Directly can relate. Akhil, correct. Very good. Akhil, that is the angle of refraction as well as angle of incidence also. Because all are parallel to each other. Okay, if they are not parallel, then that won't be angle of incidence and angle of refraction won't be same. They will be different. When medium boundaries are not parallel to each other. Okay, so to make it angle of incidence and angle of refraction same, then medium boundary should be parallel. Sharon, emergence, angle of emergence. Huh? You are talking about angle of emergence or emergent ray. Yes, Lakshmana, yes, this follows the lateral shift concept. Just I want to tell you that how easily we can apply this Snell's law in different mediums. So that is the way I want to discuss. Okay, no? So like that you can take different angles. You can now relate. Suppose in first medium, let us say that angle is theta 1. This angle is theta 1. In the second medium, this angle is theta 2. Then in fourth medium, angle is theta 4. Then in fifth medium, like last wave coming out angle is theta 5, let us say. Then what is the relation between all these angles? Will you write down? All of you try to write down the relation between angles. All of you try to write down the relation between angles. Theta 1, theta 2, theta 3, theta 4, theta 5, relation you want to write down. Try for this. I think Lakshmana, Sharon, Akhil, Jigneshwar, all you people will write down. So let me see the other people whoever wrote it down. Joshi, you have to answer. Joshi Prakash. Joshi Prakash, see whether you can write down the relation or not. Tarani. Okay, no problem. No need to type it. Just tell me whether you are able to write down or not. Otherwise, I will write down the relation. You see whether it is coincided or not. Okay. So first medium 1 into sine theta. Already I wrote. Again I write. 1 into sine theta for the first medium. For second medium is equal to means same. Is equal to for second medium or next to refraction mu 1 into theta 1. I mean mu 1 into sine theta 1. Mu 1 is the refractive index, theta 1 is the angle. For next medium, yes, I can correct. Next medium mu 2 angle is theta 2. Then mu 2 into sine theta 2. Okay, is equal to again next medium mu 3 into sine theta 3. Mu 3 into sine theta 3. Next medium mu 4 into sine theta 4. Mu 4 into sine theta 4. Okay. Next, what is the last one? This is the interesting thing. Interesting thing and hammer correct. Very good. Camel perfect. Okay, this is the last one you need to understand. Here the logic is there. One more logic is there. What the last one medium is? Last medium is 8. Then what is the refractor index? 1. One is the refractor index, and what is the angle I have taken? Theta phi. Then it is equal to 1 into theta phi. Okay. If you see all relations, you'll find one result. Can you tell me what the result? What is your observation? Now you see all the equations. You can find out one result. What is the result? One important result you need to observe. All are equal. Which are equal? What are the product is equal? That's perfect. Increase angle. Yes, if refractive index decreases, angle will increase. Mu into sin A is constant already we know, no? That's a not observation. Okay, that's a good observation. I accepted observation. But we want a result, not observation. The result is, see, 1 into sin theta, 1 into sin theta phi. Both are equal. We should not say angle is constant at the last, but something, the words should be changed. Yeah, I can understand your idea. Idea is correct. Rajeshri, yes, if refractiveness decreases, angles are increasing. Okay, now you see the first one and last one. You see the first one and last one, then you will get interesting one. What is that? 1 into sin theta, 1 into sin theta phi, Sin theta is equal to sin theta phi. Sin theta is equal to sin theta phi. Then, as assuming that you are not aware of trigonometry, Navesri correct. Vishwardhan correct. Angle of incidence is equal to angle of emergence. Okay, I'll explain that part. Okay, now sin theta is equal to sin theta phi. I'm writing. Okay, we got one equation. In mathematics, the solution will be different. Okay, when you know the trigonometry, angles, repeating angles, and all, that's a different story. So I'm not going for that. I'm only looking for 0 to 90 angles because we deal with only 0 to 90 angles. In between 0 to 90, if sine values are equal, then angles also equal. Theta is equal to theta phi. As sine is same, don't cancel sine and sine. Okay. Some people will cancel the sine and sine. Sine and sine, cancel it. Then theta is equal to theta phi. Okay. Please don't do that. You should not cancel in that way. Okay. 0 to 90, you can go theta is equal to theta phi. If it is other angles you want to find out, there is another method in mathematics. You will learn it later in trigonometry, or else we also discuss in physics. So that's a different story. Okay. We will postpone that story. Like triple R. Okay. Their function is same, then angle equal. Lakshmana, okay, partially accepted. Remove theta on both sides. Vijeshwar, what you are saying? You want to remove the theta, then 1 is equal to 5. You cancel it. We will do one beautiful mathematics. Okay, what is the mathematics? Sine, cancel. Theta, cancel. Then 1 is equal to 5. Okay, then. So we are mathematicians. On science day, we found something different mathematics. Please don't do that. Theta is equal to theta. Okay. Don't cancel the sign. Theta is equal to theta phi. That means, okay, this is mathematics now. We need to understand the physics. Theta is equal to theta phi. That means what? These two angles are same, means these two rays are what? Parallel to each other. Theta phi is equal to theta. That means both the rays, if you extend this ray, okay, this ray, these two are parallel to each other. Of course, my diagram is not appearing in that way. Okay, diagram is conventional, but they should be parallel to each other. So, what is the statement we can write on? Emergent ray will be parallel to incident ray. Emergent ray will be parallel to what? Incident ray. Angle of incidence is equal to angle of emergence, as Ignish said. That's also a good statement you can write off. What is the distance between two rays? R2S, the distance also we can find out. That's called as lateral shift. That requires little mathematics and time also, as we are aware with 1 minute. Okay, it's 8:29. If you want, tomorrow we'll discuss. Lateral shift we discuss tomorrow. Okay. Ardo. Falak, the medium is the first is air and end is air. What if it ends with different medium? Yes, different medium is different angles. Then they won't be parallel to each other. Falak, it's a very good doubt. Falak, okay. The doubt is what? If different medium is there, definitely they are not parallel to each other. So emergent ray will be parallel to incident ray. If you want, you can add the condition. I told you now. In physics, always conditions are important. Class there is no class tomorrow. Tomorrow is holiday. You can enjoy. Okay, and day after tomorrow you will have class. So guys, what is it? First and last medium. First and last mediums are same. Okay, when first medium is same as last medium. Vijayeshwar, Tarni, thank you. Happy Shivaratri to all. Okay, Lord Shiva should bless you with good health and good physics. Because if you know physics, you know everything. Maths and chemistry, everything. Joshi Prakash, okay? Cool air or the hot air. No, they don't have same refractive index. They will have different refractive index. As air getting hot or hotter, the refractive index decreases. That's why you will see the mirages on the road when you are traveling on summer days. Now, summer came, no, just ended. Okay, if you are traveling on afternoon on a for the black tar road, then you see the water type structure, okay, in front of you at long distance. Okay, that's called as mirages. That is because of happening hot air. As the air is what do you say that? In touch with the ground, that will become hot, and that refractive index changes because of that phenomena happens. Cool air has exactly correct. Get correct. Cool air has high refractive index than hot air usually, but there is no particular principle in that. Okay. Hot air will have less density. Cool air will have more density. That's why I think in your social studies or somewhere you studied like a cool breeze. Air goes from sea to land. Air goes from land to sea phenomena also I think you have seen. I don't know whether you remember it or not, but that is also happens because of this phenomena. Because of density variations, because of pressure variations, then air travels from one place to other place. Okay? Sea breeze and land breeze. Correct. Vivekananda, happy Science Day and happy Shivaratri again. Bye. You're saying bye. I didn't say bye. Akhil, yeah, I'll start the graphs also. Just I want to give you a little idea about this refraction, then we'll move to the next part also. No. I'm saying that refractive indexes are not same. Hot air will have less refractive index. I think cold air will have more refractive index, but not true always. Again, we have to see the numbers. Understood? They don't have the same refractive index. They will have different refractive index. Very good, fellow. Once you go with the mirage concept, I think the spelling is MIRAGE. Mirage formation on the road. Okay, usually I am very bad at spellings. So if any mistake is there, correct it. But that is the thing. Okay. Once you type in the Google, you will see that phenomenon. Okay, if you have any doubt, we'll discuss it. No problem. Partho, what about the BIPC students? They don't have maths to learn physics. Partho, BIPC, see, mathematics means you don't require a lot of mathematics. High extreme mathematics is not required for learning of physics. At least basic mathematics is important. Like calculations, equation solving, 2x plus 3 is equal to 7. What is x value? Ax square plus bx plus c is equal to 0. Quadratic equation. So like that, whatever 10th class mathematics is there now, if you know that mathematics, that's enough to learn the physics. Very good, Falin. Nice. Revise it. And still, if you have any doubt, we'll discuss. Don't worry. Exactly. Water appearing on road phenomena. Yes, that's only knowledge mirrors. Okay, all of you go through it once you revise the mirrors. If you want, we'll discuss. Tomorrow we discuss variable refractive index. If refractive index is continuously increasing, how the ray goes. If refractive index is continuously decreasing, then how the ray will travel. Even you have some phenomena like apparent position of star. Apparent position of star is there in your textbook also. I think I've seen it. I remember. In state board textbook also. Scattering phenomena is there something like that. Okay, so let us see atmosphere refraction. Yes. Okay, so let me also once see your textbook. Optical illusion. Yes, Vivek, correct. Mirage is an optical illusion. Okay, so if you want, we'll discuss that part. Okay, so all of you enjoy tomorrow. Day after tomorrow we'll meet. Thank you so much. Okay, once revise this phenomena. Don't forget. Yeah. Bye for today.
Yeah.